Okay, so now that we're done with the subsurface scattering and creating a matcat based ramp um, texture for our modified shader, let's talk about diffuse lighting. So most of this is going to be theory, and then eventually we're going to start getting into code as we move towards the modifications of the Lambert diffuse. So let's first start off with rough surfaces. Okay, so let's talk about the roughness of a surface. And so here's one example of a yellow jacket. It has a variety of different levels of shininess on its body. So in general, as you can see, the yellow jacket's mouth and face area is composed of an exoskeleton. It's fairly shiny. It's pretty smooth. And then because it's pretty smooth, it has some kind of intense highlights around here and so on. And even its eyes are kind of shiny, and it has some intense highlights here. And in the case of a black item with intense highlights, generally it's pretty dark, and then it has pretty intense highlights in the center area. Now the thing about this yellow jacket is that it has many eyes in its eye. It has a lot of separate lenses, so you have this pattern going on. The pattern actually could be considered as a form of roughness, because if you weren't looking at this close up, it would the eyes would probably look a little bit more flat, less shiny. It would probably look a little bit like this compared to the shininess of the exoskeleton. And as you can see on his antennas are a rougher texture, and so it doesn't quite have an intense highlight. It's kind of diffuse, though there is some lighting on it, but the lighting is pretty what do you call it? Pretty omnidirectional, because you don't really see any shadows anywhere. Yeah, there's not too many intense shadows, so that's one example of lighting. Here's another one, this time on a shoe. The shoe is composed of a couple different materials. It's composed of a leather type material, a plastic type material, cloth, and rubber, and then another type of cloth that's probably a lot more smooth than this cloth. So as you can see, the area that has that's smoother has more intense highlights, except for the highlights are broken up by the texture of the leather. And so this texture breaking up the highlight is actually something that's pretty important, and you can basically fake this effect by using a specular map. So specular maps are something that we are going to talk about when we get into the specular section, but this right now is just the diffuse section. So this is a bit less shiny than the yellow jacket, so as you can see, the highlight is not quite as intense and it's more spread out. And this is on a black surface too, but even though it's not as intense, you're kind of getting it's not quite as dark in the areas that don't have the highlight. This highlight back here is part of the Fresnel effect. I will get into this later. That's going to be the last topic for this tutorial. This area that is plastic has a really bright, shiny highlight, and you don't really see much diffuse lighting around on this piece of plastic. But you do see a very strong diffuse highlight here, so you kind of have all this area lit up, and you kind of have a little bit of a shadow back here, and then over here it's a whole lot brighter. You kind of have a diffuse highlight going along here, and then you kind of have a diffuse shadow here, and then this area and this area is kind of your mid lighting. So when it comes to diffuse highlights, basically it's just, you don't have pure diffuse. You don't have something that looks like this all the time. There is a bit of a highlight on a diffuse object, basically. So in other words, no object is purely diffuse. All objects have a little bit of a highlight to it. Unfortunately, when we talk about Lambertian lighting, you're not really going to be able to create a diffuse highlight like how you see here. That's pretty much impossible. Instead, what you're basically going to do is you're going to create an equal area of lighting, and then it can fade towards a shadow. And as you can see in this picture, the shadows are not very dark, which is something that you're going to want to keep in mind here. And this is a real image. Now, for an even rougher material, you've kind of got no highlights. You've got no diffuse highlights. Everything is pretty much just one solid type of lighting. There's no area that's really brighter than other areas. You might have a slight increase in lighting right here before we go towards the shadow. And as you can see, this shadow isn't too dramatic. What you probably do notice here is that it seems like some of the texture of this leather is catching some of the highlight. Again, this is something that you could fake with a normal map or a specular map. The painted metal here has a specular component. You can clearly see the laces, not so much. The laces are almost entirely evenly diffused, though you can kind of see a little bit of more of a highlight on the laces than the leather. And then the rubber is the same thing. There's kind of a highlight going on, a diffuse highlight going on around here, while this area is just pure diffuse as it goes into a shadow. And you have a secondary light over here, and if you notice, the stitches are made of a little bit more of a shiny material. So this is another example of diffuse, and this right here is pretty much pure diffuse lighting. There's no highlights like there was in the other shoe, where you can kind of see that this diffuse material has a little bit of a highlight. But in both cases, there's no dramatic shadows. So this is an outdoor scene of a house and what I believe is a church back here. There's a lot going on in this picture because the light source is actually coming from behind this building, but the ambient lighting is still allowing us to be able to see the back of this building. So basically we're actually inside of a shadow, and as you can see, as a light as bright as the sun is still able to create enough light scattering that you could still see, you could still see things that are sitting inside of a shadow. Though, as you start to create recesses in an object, that's reducing the amount of, I guess, light bouncing that's going back and forth, and so this area becomes a little bit darker. And then you also have this effect of the light bounces are kind of allowing some of this yellow color from this building to reflect onto that white building. That's something that's extremely important, and I think gets overlooked a lot, but it also, I think it's kind of computationally heavy, so it may not necessarily appear in video games, so I do understand that it should appear in movies, and I believe it would appear in static renders. So this wall is not smooth. I mean, it's smooth, but it's not shiny. It's not a high polished surface, but it still has a pretty intense lighting, even though it's very even. And in this case, the shadows are quite a bit darker, but they're not pitch black. And that's, again, something that you want to keep in mind. Also notice that there's reflections in the windows. Even though this is facing the opposite direction of the lighting, that's something that is seems to be missing even from some of these current gen video games. So here's a last image, and there's a lot of different things going on here. This image was taken, I think, by a man who was bringing different objects for bears to play around with. Interesting story, but you might be able to find it online. But there's a variety of different levels of smooth surfaces. The vegetation is semi-smooth, and it is another surface that is diffuse but has a bit of, can obviously hold a bit of highlights. The grass even more so. I would almost say that the grass is more of a specular texture than a diffuse texture. But it might honestly be a material that's kind of in between the two. The camera tripod is obviously a smooth surface, and it is specular. As you can see, there are some areas that have specular highlights, but it's sort of inside of a shadow, possibly. Not really. Maybe there's a tree. I don't really see any shadowing on the ground, but it's not really picking up any lighting for some reason. I guess it kind of has a diffuse lighting here and a little bit of specular on the side, so maybe it's not as shiny as I thought it was, but it's probably plastic, I guess. The lens, on the other hand, is pretty shiny. It's picking up a reflection, but it's hidden from the light by the, I guess, I don't know what to call that rim around the lens. And the tripod itself is picking up quite a few different reflections from the ground, but then some of that is also to reflect, well, some of that is a diffuse reflection, which is something that I'm going to talk about in the specular section. And then the bears themselves have shiny fur, but the fur shininess is broken up by the individual hair strands, and so we kind of have shininess going on, but then it's kind of broken up by the shadows from the hair itself, and then also internal shadowing, like inside the ear, and the claws are of a specular material. And then we have some shadows over here and some shadows over there. And then also notice that the shadowing is not very strong. In this case, this is an outdoor scene, so there's so much bouncing from light coming in, bouncing off this plant, which has a really bright highlight, which it seems like it would be specular, but if you notice, this highlight is also pretty spread out, so it's not small, and it's not a small highlight like this bear's eye, like you have this tiny highlight here from a very shiny surface. This is a shiny surface too, but it's almost completely blown out. So that's also something else you again have to take in consideration when we talk about specular. But in general, you have light coming in, bouncing off plants, transmitting through plants, like over here, hitting other plants, bouncing off, coming back and hitting the back of the bear, and helping to basically make it so these shadows are not that dark. And also to help make the shadows on the bear not that dark either. So that's me just basically analyzing lighting situation. And in here we can clearly see that there's some backlighting going on, and there's even lighting, so the shadows aren't that dark until we get down here. But even still, I mean, the lighting is not as dark as the shadows are not as dark as what you would see on the N.L function. Let's see if I can, let me pause this really quickly. Okay, so I've come back with another image. This was an old, I think, lighting model. I don't know if this was tested on Unity, if this was a part of something NVIDIA was doing at some point or what, but in general, you can kind of notice that there's some problems here. And let's just ignore the highlights for now. Let's just take a look at these shadows. So I don't know what exact type of lighting they were going for, but it's pretty obvious that these shadows are extremely dark. And this is because of the way the N.L function seems to look when you go from the most intense lighting at 0 to the least intense lighting at 1. You go from basically pure white to pure black. Now, as you could see, even in this picture that's not under extremely intense lighting, you don't see shadows being pure black. You don't see anything turning pure black. Even if we look down here, you can still see that this is a gray color. But in this picture, I mean, this section is pure black. So the Lambertian function basically is represented the way that I had originally shown a spear when I first when I was first showing the ramp, when I was first showing you how to do a make a ramp. Let's see if I can find I should have a ball that just shows the Lambertian. Well, actually I do have something. So this is the Lambertian diffuse looking head on. Just ignore everything over here. I'll get to that in a little while, but this is basically the way Lambertian looks. Lambertian diffuse looks head on. When we're not head on, we get this look. So you'll start to see the backside, and the backside looks kind of black. So that's pretty much it for rough surfaces. I guess I may be missing a few things when it comes to rough surfaces. So I guess what I should say is this is basically the gist of it. So as you go from surface that's very smooth to a surface that's a little bit less smooth to a surface that's pretty rough to a surface that's extremely rough, we start to have less intense highlights. So you might start out with a highlight that looks like this, but then the highlight gradually decreases into a material where there's no highlight at all. And in between that, you have many materials which kind of have somewhat of a highlight, or kind of are mostly diffuse with some degree of a highlight. So in general, the Lambertian model is only modeling this type of diffuse, and that is basically your base lighting. And then after your Lambertian lighting or your diffuse lighting, you have to put a specular lighting model on top of it. And the specular lighting model should be able to you should be able to adjust it so that you could even get something like this, where you have mostly Lambertian lighting and you have this kind of very soft highlight sitting on top of it. That's basically what we're going to do in the shader. But in general, I just needed to explain the roughness first. Then I will show you what the Lambertian model actually kind of looks like. I mean, I've already showed you kind of how it behaves, but I want to get a better picture. So this is the end of this tutorial, and then after that I'm going to move over to what is Lambert, and then immediately go over into half Lambert, since I've already kind of alluded into what the modifications are going to be for Lambert, but I haven't exactly explained why in great detail this needs to be done.